On September 5, 1977, humanity launched one of the most extraordinary missions in history, Voyager 1. Built by NASA during an era when computers were less powerful than modern smartphones, the spacecraft was originally designed for a relatively short mission, to explore Jupiter and Saturn alongside its twin probe, Voyager 2. No one could have imagined that Voyager 1 would eventually become the most distant human-made object ever created. Originally planned as a 5-year mission, Voyager 1 has continued operating for nearly half a century. During its journey, it completely transformed our understanding of the outer solar system. As Voyager approached Jupiter, it revealed a world unlike anything scientists expected. The spacecraft discovered violent storms larger than Earth itself, massive lightning systems, and volcanic eruptions on Jupiter's moon Io, the first active volcanoes ever observed beyond Earth. Then came Saturn. Voyager captured breathtaking images of Saturn's rings, exposing intricate structures and hidden patterns never seen before. It studied mysterious moons wrapped in thick atmospheres and icy surfaces, revealing that the outer planets were not simple gas giants, but dynamic and evolving worlds. These discoveries revolutionized planetary science forever. But Voyager's greatest achievement was still ahead. After completing its planetary mission, the spacecraft continued moving outward at incredible speed, traveling farther than any object humanity had ever sent into space. Year after year, it pushed toward the invisible boundary marking the edge of the Sun's influence. Then, in 2012, history was made. Voyager 1 officially crossed the heliopause, the boundary where the solar wind fades and interstellar space begins. Humanity had entered the space between the stars for the very first time. This historic moment transformed Voyager from a planetary explorer into an interstellar messenger. Today, Voyager travels through a mysterious region filled with charged particles, magnetic fields, and cosmic radiation known as the interstellar medium. Even billions of miles from Earth, the spacecraft continues sending valuable scientific data back home. The information it collects has stunned scientists. Voyager detected unusual plasma waves, unexpected energy fluctuations, and strange particle behavior unlike anything researchers predicted. Some of these readings challenge current theories about how interstellar space behaves. Scientists believe these discoveries could help explain how galaxies evolve and how cosmic radiation moves through the universe. Some researchers even speculate that Voyager's data may someday contribute to understanding dark matter, the invisible substance believed to make up much of the universe's mass. Among the most intriguing findings are repeating signal patterns hidden within the plasma wave recordings. While most scientists believe these patterns result from natural interstellar interactions, others wonder whether unknown cosmic processes may be involved. The idea of extraterrestrial communication remains highly speculative, but Voyager's discoveries continue fueling humanity's imagination. What makes the mission even more remarkable is the fact that Voyager still operates using aging 1970s technology. Powered by radioisotope thermoelectric generators, the spacecraft survives extreme temperatures, intense radiation, and unimaginable isolation. To conserve energy, NASA engineers have gradually shut down non-essential systems, carefully preserving the remaining scientific instruments. Every signal Voyager sends now takes over 19 hours to reach Earth. And yet, despite its age and distance, the spacecraft continues moving deeper into the unknown. Voyager 1 is no longer just a machine. It has become a symbol of human curiosity, proof that even with limited technology, humanity can reach beyond the boundaries of the known universe. As Voyager 1 travels farther into interstellar space, it carries something extraordinary with it, a message from Earth itself. Attached to the spacecraft is the famous Golden Record, a time capsule designed to communicate the story of humanity to any intelligent civilization that may one day discover it. Created by a team led by Carl Sagan, The record contains greetings in 55 languages, sounds from nature, human laughter, music, and images representing life on Earth. From classical compositions by Beethoven to rock and roll by Chuck Berry, the Golden Record captures the diversity and creativity of human civilization. It is more than a scientific artifact. It is humanity introducing itself to the cosmos. As Voyager moves through the darkness between stars, it also continues recording strange plasma vibrations within interstellar space. Scientists convert these plasma waves into sound, creating eerie audio unlike anything heard on Earth. These haunting tones are the voice of interstellar space itself. Recently, researchers studying Voyager's plasma recordings noticed unusual repeating structures and rhythmic patterns hidden within the signals. Most scientists explain these as natural interactions between charged particles and magnetic fields. However, some researchers connected to the SETI Institute have explored more speculative possibilities. Could advanced civilizations someday use plasma fields as a communication medium across interstellar distances? At present, there is no evidence proving alien communication. But the idea highlights how little humanity still understands about the deep universe. Voyager's journey reminds us that space is far from empty. Interstellar space contains invisible magnetic structures, cosmic rays, energetic particles, and forces that shape galaxies themselves. Every new discovery challenges scientists to rethink existing theories about how the universe works. Some findings suggest that the heliopause, the boundary Voyager crossed, is not fixed at all. Instead, it expands and contracts with the Sun's 11-year solar cycle. This dynamic interaction between solar winds and interstellar pressure reveals that our solar system exists within a constantly shifting cosmic environment. Voyager's discoveries continue influencing future missions as well. Projects like Breakthrough Starshot aim to send tiny probes toward nearby star systems at a fraction of the speed of light. These next-generation concepts are inspired directly by Voyager's legacy. Explore farther, think bigger, and never stop searching. Perhaps Voyager's most emotional contribution came in 1990, when it turned its camera back toward Earth from nearly 6 billion kilometers away. The resulting image became known as the pale blue dot. In the photograph, Earth appears as a tiny speck suspended in a beam of sunlight, almost invisible against the vastness of space. That image forever changed humanity's perspective. It reminded us that every human being who has ever lived, every civilization, every triumph and tragedy, exists on that fragile little world drifting through the cosmic darkness. Voyager's mission is ultimately more than science. It is the story of humanity's desire to understand the unknown. A story about curiosity, courage, and the refusal to stop exploring. Even now, as its power slowly fades, Voyager continues traveling deeper into the galaxy, carrying our dreams, questions, music, and memories into the endless night between the stars. And perhaps someday, long after humanity itself is gone, Voyager 1 will still remain out there, silently crossing the cosmos as the eternal messenger of Earth.